So in this question we're given a diagram with some triangles, so let's just put that up there, and we have PQ as a continuation of LN. These are both equidistant from the lines from the x and y axis, and we want to know what combination of the transformations will map this triangle onto this triangle. So we're just going to test out each possibility and see where the triangle would end up. So let's start with A. So A is 1 then 2, so it's reflection in y equals 0, which is this line here, followed by a rotation 90 degrees about the origin. So let's have a look what this looks like. Well, reflection in the x-axis looks like this, and then we're rotating it around here, which will look like this. Even if you can't be 100% sure of where the rotation will end up, you know that it's going to end up in this quadrant if it's rotating around. So it clearly can't rotate onto this. So we can rule A out. Now let's have a look at B. So we've got our diagram again. The first thing we're doing for B is 3, which is reflection in y equals x, which is, again, we don't need to know exactly what's going on, but it's going to reflect it somewhere in this quadrant here. And then we're going to do 4, which is a reflection in x is 0, or the y-axis. So we can see very clearly that it's going to take it over here. You don't necessarily need to draw all of these out every single time. If you can think, well, something reflected in x equals y is going to kind of stay in here, and then it's going to come over here, then it's clearly not going to end up down here. So pause the video and see if you can do the same thing for C, D and E. So let's do C and D now. So hopefully you found that we can rule C out, and we'll explain why that is now. So C is 5 then 4, which is a rotation 180 degrees about the origin, followed by reflection in the y-axis. So we're rotating around. We're just going to join the origin up to each of the points of the triangle, and then imagine this line rotating around. It's a lot easier than trying to picture the whole shape at once. So we do that, and we get these lines down here, because this line would come around 90, 180, this one comes 90, 180, and this one 90, 180. And so we can connect them up and see that our rotation would give something like this. Now the next thing we're going to do is 4, which is reflection in x equals 0, which is the y-axis here, and we can see clearly that that's not going to give us what we want, because this point's going to end up down here, and it's clearly not going to be completely on top of this triangle, so we can rule C out. So now let's have a look at D. Now for D, again, we want to do some rotating, so we're rotating 90 degrees about the origin, and then we're rotating 180 degrees about the origin. So let's first do the rotation of 90, which would give something which looks like this. Again, we've just drawn the points and rotated them around, and we connect them up like this. We're then going to rotate around 180 degrees further, which is going to, we can see from the first two, give us exactly what we want. So it turns out that D is the correct answer. It's going to rotate 90 and then 180, and we'll end up exactly where we started. We're just going to have a quick look at E as well, just so we can definitely rule it out. So why don't you pause the video and have a go at checking that E is not the correct answer. So E is reflection in the y-axis and then a rotation. So we're going to reflect in the y-axis first to do something like this, and then when we rotate round 180 degrees, we see that our shape is going to end up down here, which is clearly not where we want it, and so we can rule E out. And be sure that D is the correct answer.